Assalamu alaikum. Very good morning, students. I welcome you all to the lecture series by the Department of Mathematics, the New College, Chennai. Today we are going to see a problem based on eigenvalues and eigenvectors. This comes under the curriculum of B.Sc Mathematics, B.Sc IT, B.Sc CS, BCA, MCA and some of the allied courses also. So today we are going to see the problem for this particular matrix A. The first step is to find the characteristic equation for this matrix. So characteristic equation. We assume the characteristic equation to be lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. These values s1, s2 and s3 we are going to obtain from the given matrix A. So s1 is the sum of the elements of the diagonal, leading diagonal. So that is going to be 2 plus 2 plus 1. So the values are 2 plus 2 plus 1, that is equal to 5. So the S2 value is nothing but the sum of the minors of the diagonal elements. So for the element 2, we are going to find the minor. So we have to leave off the first row and first column. The rest of the elements are going to be the minors for the element 2. So they are 2, 2, 3, 1. Plus the next element is again 2. For this element we have to leave off the second row and the second column. So the minors are 2, 1, 1, 1. 2, 1, 1, 1. Plus for the element 1, the minors are 2, 2, 1, 2. 2, 2, 1, 2. So the value is actually obtained by cross multiplication. So 2 minus 6 plus 2 minus 1 plus 4 minus 2. So this is equal to minus 4 plus 1 plus 2. So the value is actually minus 4 plus 3, that is equal to minus 1. So the S1 value is 5 and S2 value is minus 1. So now we are going to find the S3 value. S3 is obtained by finding the determinant of the given matrix A. So determinant is obtained by the minors of the first row elements. So starting with the element 2. For the element 2 we have to leave off the first row and first column. The minors are 2, 2, 3, 1. So it is 2 into, the values are 2 minus 6. 2 into 2 minus 6. And the next one is, we have to go to the second element of the first row. For that we have to introduce the symbol to be negative. So minus 2 into 1 minus 2. Minus 2 into 1 minus 2. The next one is for the element 1. So it is going to be 1 into 3 minus 2 plus 1 into 3 minus 2. So be cautious, we have introduced the minus symbol only for the centermost element of the first row. So this is equal to 2 into minus 4 minus 2 into minus 1 plus 1 into 1. So this is equal to minus 8 plus 2 plus 1. The values are minus 8 plus 3, that is minus 5. So the determinant value of A is minus 5, which happens to be the value for S3. So the actual characteristic equation is, we have to substitute the values of S1, S2, S3 in our assumption. So that is going to be lambda cube minus S1 lambda square. The S1 value is 5. By the assumption we have minus S1 lambda square. So it is going to be minus 5 lambda square. The next is plus S2 lambda. S2 value is minus 1, so it is going to be minus lambda, and the next value is minus S3, and the S3 value we have obtained is minus 5, so minus into minus plus, so plus 5 is equal to 0. So the actual characteristic equation we have obtained is lambda cube minus 5 lambda square minus lambda plus 5. So to find the eigenvalues, you have to factorize this cubic equation and get 3 values of lambda. So we are going to achieve it by using the synthetic division. In synthetic division, what we do is we consider the coefficients of each term. So the coefficient of lambda cube is 1, the coefficient of lambda squared is minus 5, coefficient of minus lambda is minus 1, and the constant term is 5. So this is one of the trial and error method. So let me choose lambda to be equal to 1 as one of the value, and let us check if it is one of the values of lambda also. So by synthetic division, we have to multiply these two and write it here. So 1 times 1 is 1. So we get, by adding these two, minus 4. 1 times minus 4 is minus 4. By adding these two, we get minus 5. 1 times minus 5 is minus 5, and the constant term becomes 0. So this says lambda is equal to 1 is one of the value of lambda. After that, the rest of the terms, this 1, minus 4 and minus 5 corresponds to the coefficients of lambda square and lambda and the constant. So we obtain an equation, quadratic equation, from this three terms, that is 1 times lambda square minus 4 times lambda minus 5 is equal to 0. Now we have to factorize this equation to get the values of lambda, two other values of lambda. So we need the product to be equal to minus 5 and the addition to be equal to minus 4. We have to choose two numbers such a way that the product of those two must be minus 5 and the addition of those two must be minus 4. So let me choose them as minus 5 and 1. So minus 5 times 1 is minus 5, product is achieved. Minus 5 plus 1 is minus 4, and addition is also achieved. So from this I get lambda minus 5 times lambda plus 1 is equal to 0. So be cautious here. Lambda is equal to 1 is one of the values of lambda, but the values that we obtain here are factors of the equation lambda square minus 4 lambda minus 5 is equal to 0. Those are not the exact values of lambda. What you have to do is to find the exact values of lambda, we have to equate these two values to 0 and get the values. So if the value is minus 5 here, by equating it to 0, that becomes plus 5. So one of the lambda value becomes plus 5. The other value is going to be lambda is equal to, taking this to the other side, is going to be minus 1. We also know lambda is equal to 1 is one of the value of lambda. So these three are going to be your eigen values. So we actually had assumed a characteristic equation for the given matrix. By finding the values of S1, S2, S3 from the given matrix, we have actually found out the actual characteristic equation of the matrix A. After that, we have just solved those equations to get the values of lambda by synthetic division. This is one of the method that we have used. The first value of lambda we have assumed by trial and error method. So we have assumed that to be 1 and we have got the answer to be the constant term to be 0. So we have got lambda is equal to 1 is one of the value of the characteristic equation. So by that we have factorized the rest of the equation, we have got the other two values of lambda. So these three values of lambda are going to be your eigen values. So this concludes the first part of the video, wherein we have discussed the eigen values alone. For the same matrix, we've obtained the eigenvectors in the part 2 video, which will be in the link will be in the description section. So for the same matrix A, we have found out the eigenvectors corresponding to the eigenvalues that we have found already. So please check out those videos also, that will be very useful for you. Thank you, students.